Assalamualaikum and good day to everyone. My name is Aziati binti Azhari. I will start the presentation of our case study 2 with the title of Knee Prosthesis Implant Material. Introduction. Knee surgical implant. A surgical procedure in which the parts of the kneecap, thigh bone and shin bone of the patient gets worn out because of an injury of other conditions such as osteoarthritis and psoriatic or rheumatoid arthritis. The worn ends of the bones and any remaining hard cartilage are removed and replaced with metal and plastic parts. Implants can be either biodegradable or non-degradable, should be non-toxic and biocompatible, and should not trigger on immunological response. Therefore, the right material selection is a very important process to apply the right materials for the knee implant surgery. This study case will show the process to make the appropriate material selection that will be fit for surgical medical implant and the appropriate manufacturing technique to produce the implant.
My name is Shafika and I will present about the material selection strategy. It is a process of selecting material to a design of product. There is 4 steps of the material selection strategy. Step 1 is translations of design requirements. The process of it is element in the design requirements. We have functions, constraints, objective, and free variables. Then here is the explanations of the element. Next, for the material performance index, we have the equations of maximizing strengths and minimizing the cost. Next, here is the graph of Young modulus we express for the candidate materials. Here is the graph Young modulus with density for the candidate material. Here is the details of selected materials. We have 7 candidate material, which is stainless steel, titanium, cobalt chromium alloy, zirconia bioceramic, polyethylene, nickel titanium alloy, alumina bioceramic. And here is the properties of the material. For the step 2 is screening. Screening is the process that we state the properties that we want to analyze. For the materials, we have density, compressive strength, Young modulus, wear resistance, corrosion resistance, biocompatibility, hardness, and price. Next, we use the constraint to screening the materials to choose the 3 best materials and eliminate the 4 materials. The suitable candidate of the knee surgical implants of knee prosthesis is stainless steel, titanium, and cobalt chromium alloy. We eliminate the 4 materials due to the nickel titanium alloy and alumina bioceramic are eliminated due to the expensive price and not affordable, while zirconia bioceramics are eliminated due to the poor wear resistance, and polyethylene and nickel titanium alloy are eliminated due to the lowest compressive strength compared with the other material. Next, for the step 3 is a ranking. Here is the ranking materials to choose the excellence and best material for the designs. Titaniums, as we can see, the value of the cobalt chromium alloy is the highest. So the best material to be chosen is the cobalt chromium alloy, because titanium and stainless steel have a poor wear resistance compared to the cobalt chromium alloy. Last, for the step 4 documentations, cobalt chromium alloy have a very good properties as it's a good wear resistant that will last for the long times and have high compressive strength, high tensile strength, high strength at high temperatures that fulfills our objective, which is high strength. Then we have excellent corrosion resistance that will withstand the corrosion properties, and we have the cobalt chromium alloy, also the affordable price to be used as the materials of the knee joints implant.
Hi, my name is Muhammad Naim bin Abdul Rahim. Today I would like to talk about manufacturing process of knee prosthesis component, which is femoral component parts. As you can see from the video title, how does selective laser sintering work? I'm gonna briefly explain about it. First of all, once the metal powder are inserted into the supply container and digital instructed to the program, laser unit directed high power beam to reflective mirror. The galvo motor system will focus beam to the powder surface. Each layer of part geometry is then sintered to heated bed of nylon. Piston move the supply container up while the build chamber down, while the roller move across bed to distribute the next layer of powder. Excess powder will be swiped to the collection container. The process are repeated layer by layer until the process is complete. Now as you can see, this is the flowchart of the production process of femoral component. We begin with material selection. We use cobalt chromium as the material. Then material and apparatus preparation. We prepare the MLS machines. Then filling metal powder, heating metal powder, dispensing process and sintering process. The process of dispensing and sintering were repeated layer by layer until the product is finished. Then we left it for cooling section, and at the end, parts are removed from the platform and frameworks of support are removed from the parts, then completed with any bead blasting and deburring necessary.
For the manufacturing process selection strategy, the first step is done by translation of information. The function is set to shape the knee implant parts, which are the femoral and tibial components. Then, the best process to execute the shaping method will be selected. The constraints involved are the suitable range of part thickness, the good tolerance with the possibility to avoid the defect, the components come in different size, the support weight that ideal with the knee prosthesis user, and the production of non-circular prismatic shape. The objective has been set to minimize the cost and maximize the shaping quality. Finally, the free variables are based on the option of the manufacturing process. The 5 process candidates that have been selected are the stereolithography process, the selective laser sintering process, CLA and CLV investment casting, the automated investment casting, and the high pressure die casting. For the screening step, all the properties are stated based on the correlation of objective and the constraints that have been set. Among the properties are the mass range, the range of section thickness, the tolerance, the relative cost index, the tooling cost, and the non-circular prismatic. All the process information are stated in the table. In the ranking step, all the process properties has been evaluated based on their capabilities to shape the components. A scale of 1 to 5 marks is given. And finally, the ranking of process can be identified. From the table, the highest marks is given to the selective laser sintering process. In the final documentation steps, the SLS process properties are refined. Based on the screening and ranking process, the SLS process is the most appropriate and preferable process. It is because it can create a fully dense metal parts with good precisions and produce a wide range of section thickness. It also can produce a high complexity external and internal shape of components. Finally, this process has a low relative cost index and low tooling costs.
I'm Abdulaziz. I will present about the effect of parameter on the performance of products. Two major points on this part is material properties and process parameter. Next is material properties. Five major points in this part is corrosion resistant, compressive strength, wear resistant, material manufacturing capabilities and biocompatibility. Raw material proposed for the product on knee prosthesis, biomedical surgical implant has a resistance to corrosion. Corrosion resistant is one of the essential material properties because corrosion inside the internal part of our body will cause some damage or harmful reaction. Next is compressive strength. Compressive strength is a material's capacity to withstand load that tend to reduce the size as opposed to the load that tend to elongate. Material proposed for the product must able to withstand compressive load from the user's own body weight to maintain the structural integrity. Next is wear resistant. Wear is damaging, deformation, and removal of material that happen gradually. It is essential to select the right material with high wear resistance to ensure the implant longevity. Next is biocompatibility. Biocompatibility is another vital factor for selecting the material for the surgical implant. This is because without the biocompatibility, the material might be toxic, brittle that may cause injury to the user. Lastly is material manufacturing capabilities. The material selected for the product must be capable to be machined. This is because machinability material could reduce the manufacturing time and manufacturing cost. 5 major points in this process parameter. The first one is the thickness, mass, shape, tolerance, and material. The thickness of the product must suitable for the manufacturing process. The manufacturing process uses for this product is laser sintering. This machining process allows for the thickness of the product to be as minimum as 0.8 millimeter. So the manufacturing process uses for this product is suitable. Next is the mass of the product. The knee prosthesis mass needed to be as minimum as possible to allow the users to be comfortable. Selective laser sintering process capable of undergoing this process because the machining processes by selective laser sintering allows the to produce the product by using the lowest amount of material without sacrificing the structural integrity of the product. The third point is the complex shape of the knee prosthesis surgical implant will limit the capability of the traditional machining process. So by applying the advanced manufacturing process that is selective laser sintering will allow the process to do intricate processes of machining. Next is tolerance. Dimensional tolerance is a very crucial aspect of the manufacturing process of knee prosthesis surgical implant. The lower range of tolerance allows the product to be produced more accurate, that it will improve the product dimensional accuracy. Selective laser sintering allows the product to be produced in tight tolerance up to 0.2 until 0.8 millimeter. The last point for this part is the process chosen for the manufacturing process of new prosthesis must allow the material usage of the process. The material selected for this process is cobalt chromium alloy. So the selective laser sintering could perform the manufacturing process to this material. For the following part is testing and quality control. Quality control standard in this part will be utilizing 6 points. The first one is ASTM F1800, ISO 10243, ASTM F2083, ASTM F1223, ASTM F1672. The lastly will be ASTM F1814. I will present is product performance testing. There are 3 testing that will be utilized. The first one is fatigue test, knee wear test, and corrosion resistant test.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Zairif Hilmi bin Muhammad Zainuddin. I will present to you about the defect and the countermeasure. For the defect, we divide into two defects, which is defect on process and defect on material. For defect of process, we have discussed about stereolithography (SLA) and selective laser sintering process (SLS). And in defect of material, we have discussed on three material, which is stainless steel, titanium, and cobalt chromium alloy. The reason why we discuss about these two processes is because it is commonly used in medical, so we want to show its defect and the countermeasures. Basically, SLA is a type of 3D printing technology that uses polymers or resin to build parts layer by layer. The resins that been used is in liquid form, so the newly made parts are kind of sticky, dirty, and need to be treated. The countermeasure to this defect is to clean it and wash it with solvent to remove wet resin from the parts and further cure the parts to make sure it is safe to use for human, and dry it before use the parts in medical implant. Next process is selective laser sintering (SLS). Different from SLA, the SLA using liquid resin for its raw material. SLS is using powder material as its raw material that fuse to become a mesh with 3D form that create through CAD software. The defect of using this process is when using the powder as its raw material, the finishing component have porous surface. These defects can be countered by sealing using post-processing method such as cyanoacrylate and coating or hot isostatic pressing. Lastly, conclusion. In conclusion, this case study that we doing had exposed us to explore and make a better understanding of material selection and their processing of surgical implant materials in order to understand the structure, property, processing relationship. Thank you.